For this lesson, our focus standard comes from Grade 8, Expressions and Equations, Standard 8. Analyze and solve pairs of simultaneous linear equations. The topic for this lesson comes from our unit, Systems of Equations, Solving Systems of Equations Word Problems. Our essential question is, how do we write and solve linear systems of equations for word problems? Please take a moment, pausing the video if you need to make sure you copy down the standard, the topic, and essential question into your header along with today's date. Set up your question column and your note column and resume the video when you're ready to begin.
So the steps to solving a systems of equations word problems, first you want to define and identify what the variables are in the problem. So what is your x, what's your independent, what's your y, your dependent variables. Second, you need to write the equations for each part of the system. Most likely then you need to graph the equations. Right now we're doing all systems of equations word problems by graphing. And then our fourth step is to find that point of intersection. The coordinates are your solution, your x and your y value that make the equations equal. And then the last step is to interpret the solution in the context of the problem. So there's these 5 steps, and this is going to work every time you have to approach a word problem with systems of equations and solve by graphing. So I have a few helpful pointers here, and I kind of briefly hinted at this in the last video, but the word per is a really important word. See if we can put that in text. Anyway, and it signals a rate of change. So if you see the word per in a story problem, you definitely want to highlight it and pay really close attention to the numbers and the words around it. Because the variable mentioned right before the word per in the story problem is in relationship to your dependent variable. That is your clue to what your y variable is going to be. And then the variable mentioned right after the word per, that is going to be your independent variable or your x variable. So it tells you what your rate of change is. It tells you what your slope is. It also helps you to identify what x and y are. So really important there. So let's take a look at our example problem. So Colby and Ben are both trying to raise money for the East Coast trip. So Colby has decided that he will wash windows for $15 plus $1 per window. Ben, on the other hand, is going to wash windows for $5 plus $2 per window. And we're wondering, when will the cost to use either Colby or Ben be equal? Or rather, like, at what point will the cost for Colby and Ben be equal? So those are the relationships that we're looking for. So now we have to define the variables and get ready to start writing our equations. So remember our hints here. We're looking for the word per. So at this point in the lesson, you should have all of this information copied down. Pause the video if you don't already and get there. And then what I want you to do is look for and highlight the word per. So I see per right here, so I'm going to go ahead and highlight it, and I also see it here. So we should have it highlighted in 2 places. So this is going to help us to define our variables and begin to write those equations. So in our hint, we say the variable before per is going to be our dependent. That's going to be our y, so that's going to help us define our variables. And so here I have dollars before it. $1 specifically, but dollars is being mentioned before it. And after, I have window. So the dollar is going to be in relationship to my y variable. That's what is before it. And so dollars has to do with cost, right? The cost in dollars to hire one of these 2 gentlemen to come wash windows. So And then right after it is windows, so X is actually, we should say this is the number of windows. There we go, number of windows. So Y is my cost in dollars and X is the number of windows. And I get that just from looking at that. And over here, it's the same thing. Per right before it is dollars and right after it is windows. So my Y is the cost in dollars and my X is the number of windows. So now that I've defined the variables, I'm ready to write the equations. So take a moment before I show it and see if you can pause the video if you need to and write an equation. Our two relationships are Colby and Ben. So how much is it going to cost to hire Colby? We want an equation for that. And we want a cost for how much is it going to be to hire Ben. So again, pay attention to our helpful pointers here. Per is our rate of change. For Colby, it's $1 per window. And for Ben, it's $2 per window. And then we have some additional charges for each of them. So let's take a look and see how you did at writing those equations. So Colby, and again, writing equations, we're writing them in y equals mx plus b. So if y is the cost, I'm going to start there. And he's $1 per window. That's my m variable, right? That's my slope. So it's $1 per window. That's the rate at how much he charges. And he charges $15 just to hire him because he's got to make the cleaning solution and all that. So for him, he's charging $15 and then $1 per window. So for our equation would be y equals 1x plus 15. I've included the dollar signs, but they're really not necessary. And then for Ben, he charges, here's Ben, Ben charges $2 per window, so 2 is my m variable. And in addition, just $5 to hire him, and again, that's probably to cover costs like cleaning solutions. So here are our equations. We've now written our two equations for the two parts of our system. We're ready to move on to graphing. So go ahead, again, I'm going to have you set this up for yourself. I want you to create yourself a graph and see if you can graph these two equations onto an x and y axis. Go ahead and pause the video while you do your graphing and then resume the video to see how you did. Alright, so let's take a look. You should have a graph something like this. So on my x-axis I have number of windows, and on my y-axis I have the cost. I have that labeled here and here. And then I decided to use a scale of 5, so I'm going to have 5, 10, 15, 20 for the cost of hiring either Colby or Ben to wash windows. And on the x-axis I chose to also go by 5s. So, and then really that comes from looking at my b values that just seemed to make sense. So let's see if we can identify. So this blue line is my line for Ben, because he starts out at $5 and then it goes up 2 over 1, 2 over 1. And Colby's, he starts out at 15, so he's the red line, and it goes up 1 over 1, up 1 over 1, up 1 over 1. And so now we've graphed them. This gives us a lot more. We have an equation and we have a graph, and that's going to give us a lot of information to see how we can further analyze this problem. So as soon as we graph it, we want to look for that point of intersection, and I've actually already labeled mine here on the graph. It's right here. As long as we've graphed our lines well and precise, as we've been talking about all year, then finding points of intersection, finding solutions to systems by graphing should be fairly easy, and it should be really obvious once we get graphed. So right here at 1025 is our point of intersection. And so again, just kind of putting this in context, this 10 represents that at 10 windows, and y is representing the cost of $25. But what does this mean in relation to hiring Colby and Ben? And so taking step 4 and going a little bit further with it, we could say that to wash 10 windows, the cost for hiring Colby or Ben is $25. So if I decide to hire them and I only have 10 windows at my house that I need them to wash, then it doesn't matter if I hire Colby or Ben, the cost is going to be the same. However, if I have less than 10 windows, who's going to be the better deal? Right? It's going to be this one. If I have less than 10 windows, then it's a good idea to go with Ben if I'm trying to be economical. If I have more than 10 windows, then Colby becomes the better one for me to hire because it flattens out after a while. He's only charging $1 per window, and so if I have, say, 12 or 20 windows, then Colby's going to be the better deal. And lastly, as a lot of you have gotten really good at this, how can we check? We want to always have a way to check and make sure we've done our work correctly. So we can always check our work by substitution when we have a solution. And really, this is that point, right? These are the x and y values that should make the two equations that we wrote equal to each other. And so I'm just going to go through that real quick and as an example, as time is ticking, I know. So our solution here was 10, 25. So I've just taken the 10 in each of our equations for Colby and Ben, and I've plugged that in for x. I've substituted that in. I also substituted 25 in for y. And I'm just checking to make sure if I use 10 and 25 for Colby, does it check out? And sure enough it does. I come down to 25 equals 25. I do the same thing for Ben. If I plug 10 in for x and 25 in for y, do the calculations and it works out. So we can say that since 1025 satisfies both equations, we know our solution is correct.